Let us consider the problem of verifying whether the given function f of x is a probability density function. To verify whether the function is a probability function, the first condition to be verified is f of x is greater than or equal to 0 for all x. Whatever be the value of x you substitute here, you will not get any negative value, right? If any value from 0 to 1 is substituted, it is going to be f of x is going to be positive. And if you substitute the lower limit 1 here, you are going to get 1, and the upper limit 2, you are going to get f of x is 0. Nowhere you are getting a negative value. So f of x is greater than or equal to 0 for all x. The first condition is verified. And the second condition is you should integrate f of x over the entire range. The lower limit of the problem is 2. The upper limit of the problem is, the lower limit of the problem is 0. The upper limit of the problem is 2, right? Over this range, you should integrate. If you want to integrate over this range, you can observe from 0 to 1, the function assumes a different value. From 1 to 2, it assumes a different value. So, you should split the integral into integral 0 to 1 f of x dx plus integral 1 to 2 f of x dx, right? From 0 to 1, f of x is x, and from 1 to 2, f of x is 2 minus x. Fine. So, x on integration gives x square by 2. Put the limit from 0 to 1. 2 on integration gives 2x. Let us have the limit from 1 to 2 separately, or you can do it together as per your wish. X on integration gives x square by 2, and the limit is from 1 to 2. Let us substitute the limits. 1 by 2, upper limit for x 1 square is 1, minus lower limit for x 0, plus 2, upper limit for x is 2, minus lower limit for x is 1, minus 1 by 2, upper limit for x is 4, minus lower limit of x 1 square is 1. So you get 1 by 2 plus 2 minus 1 is 1, 2, minus 4 minus 1 is 3 by 2. Fine. So take 2 as the LCM. Here you have 1. 1 times of 2 is 2. 2 times of 2 is 4. Minus 3. So you get 2 by 2, that is equal to 1. So if you integrate over the full range, therefore when you integrate f of x over the full range of x, you get 1. So the first condition, that f of x is greater than or equal to 0 for all x, is satisfied. And the second condition, that when you integrate over the entire range, you are getting 1. So 1 and 2 implies that f of x is a PDF, probability density function. You have verified. Fine. Okay, let's go to the next problem. See, verify whether f of x is a PDF. One function is given. Let us verify. Here the range of x is 0 to 2. So for 0 to 2, you should integrate f of x. The first condition is of course true. F of x, whatever be the value of x you substitute from this range, you are going to get a positive value. You should not get a negative value, right? If it is a negative value, it cannot be called a probability function. The first condition is satisfied. For verifying the second condition, see, you should integrate from 0 to 2. Over the entire range, you have only one function. Unlike in the previous problem where you had two different functional values for two different intervals, you have only one function over the entire range. So it is 3 by 4 x into 2 minus x dx. Let us have 3 minus 4 outside. So you are going to integrate 2x minus x square. Fine. So have this 3 minus 4 outside. 2x on integration gives 2 times of x square by 2. The limit is from 0 to 2. X square on integration gives x cube by 3. The limit is from 0 to 2. So 3 by 4. Here 2 and 2 can be cancelled. Upper limit when substituted for x square gives 4. Lower limit gives 0 minus 1 by 3. Upper limit 2 when substituted for x cube gives 8. Minus 0 cube is 0. So you have 3 by 4 into 4 minus 8 by 3. Fine. So 3 by 4. If you take 3 as the LCM, you get 12 minus 8 by 3. 3 by 4 into 4 by 3, which is equal to 1. Right? This is your first condition, and here second condition. See, if you substitute any value from this interval, you will get only positive value here. Have a manual check. Put x equal to 0, you are going to get 0. Put x equal to 2, you are going to get 0. Put x is equal to 1, you are going to get 2 minus 1, 1, 3 by 4. So you are not going to get any negative value. So you have written as f of x is greater than or equal to 0 for all x. And the second condition, so integral 0 to 2, if you integrate over the entire range, you get 1. This is the second condition. So the first and second condition together tell you that f of x is a PDF. Both the conditions are verified. Okay. This is how you check that f of x is a PDF. Two conditions are to be verified. Remember. Thank you.